Okay, and this is actually the, how do I say, the last lecture for the Tableau part. So next week, actually, we're going to have a break so we can work on an individual work for the first coursework, and which will cover more in the lab in terms of goes through the individual work requirements. And this week, we're going to talk about tabular data, essentially the data you can find in a spreadsheet in a table form, and which is probably the most common data form you will see. But first, we'll go through, just quickly cover or review the things we covered in the last 2 weeks, actually. And so I think 2 weeks ago, we covered the markers and channels, which we didn't finish until last week, and it was slightly overrun. And so we mentioned the concept of marks, and which used to represent an item in your data. So for a table, that's usually a row in the table. So each point will be one data item. So that means it can have many different data attributes. And so you think, say maybe one item is each product in the supermarket. Then you have profit, price, name, and weight, etc., etc. And then you have there's many different ways you can represent the data item visually. So this is what we call different types of marks. You have 1D mark, sorry, 0D mark, which is point, and 0D means 0 dimension. That means it does not have any width or height. Excuse me. So the points, and even practically when you draw them, it has to have certain, say, radius or size. Otherwise, you cannot see it literally if it's just one single point. It will be very hard to see. But conceptually, and it does not have width or height, something you cannot use to represent any attributes. And so the next one would be 1D mark, and 1D mark is a line. So it only has length, which is one dimension, which is why it's called 1D mark. And you can use the length to represent one attribute, usually it's number, and this can be curly line as well. And you have 2D marks, which are area. So here are the more complex examples of 2D marks. And the more common ones you will see 2D marks is more like a circle or square or even triangle, some basic simple shapes. And in this case, you have both the width and height to represent something, or you can just use the area. And the 3D mark is also possible. You can use a cube to represent data items. But this is not common just because it's not very effective. And also, it's important to be aware that it's not necessarily the higher the dimension, the better. Actually, it can be potentially opposite. And the 3D mark is one has the most dimension here. It actually is the least effective. And also, it doesn't necessarily mean 2D mark will be better than 1D. It really depends on how many attributes you want to represent. And sometimes you only want to represent one attribute. So 1D mark line, for example, a bar chart could work very well. Okay, and then we talk about the channels. And channels is the kind of like the visual attributes of the mark that you can change or use and to represent attributes. And so you can change the visual of the points to represent attributes. And so we talk about different possible channels, including positions, so where the mark is located in terms of X or Y or both. And you can change the color of the mark to represent some attributes from data and use shape. Obviously, this is only possible if you have a 2D mark and you can't have a shape for 1D, sorry, a 0D or even 1D mark. You can have the tilt of the line to represent something. And more commonly, it's more like you can use length, area, or volume to represent quantitative or numerical values. Okay, and so these are the channels. And then this is probably the most important thing in terms of you want to learn, probably even for this module. And so for each channel, and some are more effective than the others when represent certain type of attributes. That's what this table is for. We have the left half are the channels that you can use to represent and quantitative values or numerical values. Whereas on the right-hand side are the channels that you use to represent categorical or sometimes called nominal attributes. And these two lists are ordered from the most effective on the top and to the least effective at the bottom. And so when you create a validation, you should always start from the top. And for example, there's no reason, say, you will start from here and you start with color or even start with size, if say the position is available. Similar on this side. So in theory, there's nothing stop you to use any attribute to, use any channel to represent any attribute. For example, even here on the categorical side, it's only listed the 4, and there's nothing stop you, for example, to use the tilted level, one of these channels, to represent a categorical attribute. And that's still possible in theory, and it just says it's very ineffective. It's not even listed or discussed here. Okay, and so the general principle is, and you need to first decide which attribute is most important in terms of validation, and what that attribute type is that a number or is that a category? And then if it's a category, and you choose the most effective and channel that is available for the category value attributes, or if it's number, you choose one of these. And then you go on to the second attribute, that's the most important one, and then you pick one of the most effective channel that's still possible. And so that means you need to first decide and how many attributes you want to display or show in your validation. What are the order of importance? What are the most important one? What are the second most important one? What's the third one, etc., etc. And then for each attribute, you pick the most effective channel that is available now, and depends on the type of the attribute, whether it's number or category. And for example, if the most important attribute is a categorical attribute, and then you use the location of the nodes to show that, then that channel is taken. And then we have the second attribute. If it's a number, or second most important one is a number, you cannot use these anymore. And because the position is already used to represent the first categorical attributes, so your best choice will be using the third one, which is a line. So this kind of also give you a potentially and help you to choose the type of the chart as well. For example, you decided to use line to represent some attribute value, and so that potentially means one of the options will be using bar chart. Okay, and so that's what we covered in the last week and the week before. And the last week, we also spent some time talking about the rules of sums. And these are something similar to the idioms and slightly less restrictive in the sense there might be more cases which are exception or does not follow the rules, but usually it's still general good to have them, just keep them in mind. And the first one is no unjustified 3D. And so when 3D is kind of fancy and maybe interesting, but usually, and it has its own problems when you use that to represent data, for example, and the depths, and just because it's very difficult to perceive or less effective. And if you check here, you can see, and if you use depths to represent one attribute, and it's not very effective for numbers. It's quite low down, it's halfway down the entire list. And then also you can have occlusion, where it means, and the things in front could block the things behind. Sometimes, for example, you have a big one here, you don't even know what's behind because it's completely blocked. And also you have the perspective distortion, in the sense the things further away and from the viewer will become smaller, but also the distance will become smaller as well, and introducing certain distortion, which is not good for people to estimate the values. Okay, the second rule, it says eyes and beats memory. So if you remember, we showed this video about showing the flights between the Europe and US and how that happens over time. And as an animation, it's very interesting to look at and impressive. But it's not very easy in terms of do any analysis on the data, because we as humans is not very good at remembering what happened, to say, just a few seconds ago in the video. A much better way could just be showing the flight and situation for each minute and for each time point with a small validation. Okay, and next one is called resolution over immersion. So this is really about this more recent and technologies like virtual reality or augmented reality. You use two views, providing two slightly different views to the left and right eyes. And as a result, you will have this kind of more realistic feelings. And this is useful when, say, being very realistic or have the feeling of in the environment is important. So this could be a good example when you want to do, say, interior design. Maybe the sense of being right there inside the room is very important. So that might be a good reason to use it. But the downside is you effectively reducing your display area by half. So basically you're showing two very similar, only slightly different images. That means you're effectively only using half the total display to show the information. The other half is more or less just a duplicate what's on the first half. And that's not used. So as a result, you have much less display space, which is an important factor. And because it can be potentially very important if you have lots of things to display. Okay, and so also we talk about general rules when you design visualization for very large data set. And the examples we use was a Google map. And you can easily imagine if we want to display the map of the entire world, and it's very difficult to show everything at the same time. It's not even possible. I mean, even if you can, we as user cannot really make sense of it. It's just too much information. So what you do is you provide an overview first. And so this is an overview of the entire map. And you allow user to zoom and filter. So user can zoom in at certain areas, for example, and the user currently looking at this area. And the user can choose what to show on the map. Do you want to show the cities, to show the road, or maybe show the, say, the railways or some other information? And then finally, details on demand. And so after the filtering, there still might be too much information. You cannot show at the same time. And in this case, by default, the map would show mostly highlighting the cities and maybe the roads. And there's still lots of information about each cities. And what user can do is to either mouse over or click on the city to see more details. And so that's the details on demand. Okay. And then we have one final kind of rules of thumb or recommendation, and it's always function first and form next. So I think that's what we have been saying many times throughout this module. It says, what makes a good visualization is it achieves, is it effective? It says it can support the type of analysis it targets. Really depends on the type of analysis. That's the why part. Okay, it's not about how beautiful, how complex, or how fancy, or how colorful, and the visualization is. I mean, that's also useful. In the ideal case, it's both functional and aesthetic. But if you have to choose between one of these, you always choose function first and the form next. Okay, and I can just turn on the blinds because currently the sun is on my face. I can't really see anything on the screen. Okay, yeah, still a little bit, but much better than before. Okay, so today we're going to talk about tabular data visualization. And so if you remember, this is, I mean, at the very early at the beginning of the module, and one of the first thing, we covered about is the different types about data. So you have the data types, data set types, and attribute types. Okay, and then today we're going to just focus on the tabular data or the table data set type and the different ways to visualize table data. And partly because this is the most common ones and that you will encounter in your future job or actually common analysis. Okay, again, just some concepts already mentioned, but just repeat again. And in terms of keys and values, so the keys are the independent attributes, and usually they are unique. So each data items in the table should have a different key. It cannot be the same. So the examples could be your student ID number. So no two students would have the same ID, and that's the key. And so you can have one key. For example, you can use student ID as a way to uniquely identify a data item. And sometimes it's not possible. And so you have multiple keys. And so, for example, if in general, you need to identify a person and who don't really have an ID, don't have something ID, and you can potentially use name, but usually just use name is not enough because people can have same names. And you might have to including a second attribute, which is, let's say, date of birth. And to be safer, you might including a third attribute, which is address. Then you have a 3 key and table using these 3 values to uniquely identify each data items. So when you have 2 key and you need these 2 keys, so just name and let's say date of birth to identify a person, and you can have multiple keys. So when you have 2 keys, you can see and the key 1 and 2 form 1 dimension, and you can have other attributes, multiple ones, which make it looks like a cube. Okay, and then we have the values, the dependent attributes. And so just think, say, if you have the student ID as the key, and then the value would be other attributes about a student, like their name, their age, and which program they are studying, their grades, etc., etc. Yeah. And as we already mentioned, and you can have 1 key and table 2 or 3, etc., etc. Okay, to visualize tabular data, and we're going to start with some more basic type of plots. And so the first and most obvious one is scatter plot, which most of you would have known. Okay, and so just as we mentioned before, and we're going to talk about the markers and channels, what are they used in each of these different type of chart. And so we'll start with the scatter plot, and then say what they are good for, like the idioms and like recommendations, in what situation this will be the good choice to visualize the data. Okay, and so first, Can someone tell me what would be the mark in a scatter plot? You can type in the chat if you don't want to say.
Circle, color.
Circle and color. Okay. Thank you. And anyone else? What is the mark in
Points. An area.
Area? Okay. Yeah. Point. Okay, there's also people typing point. Yeah. So, and this is actually the picture I'm showing here is maybe slightly misleading, and it's maybe not a best example of scatter plot. And strictly speaking, and in the scatter plot, you only have points. These points would not have color or sizes usually. And so actually the mark is point. And so you're only really using the position of the mark or the point to represent some attributes. And in this particular case, we're actually also using the size of the bubbles, sorry, the size of the points or the color of the points, and to show the some attributes. And then here, the mark becomes 2D and it becomes area. Okay, yeah. And then let's have a look about the channels and what channel is used in the to represent attributes in a scatter plot. And you can either talk about a scatter plot or bubble chart. And so bubble chart is a name for a scatter plot where you have circle have sizes, which is actually can potentially be a problem because, for example, you can have a big circle which covers or blocks a few other small circles. Okay, and anyway, and back to the channels. What are the channels used? And in a scatter plot, and I saw already one message say in the chat, it says channel is color. And certainly, and for this example, and channel is, color is used as a channel to represent something. And just, I want you to be aware, color and it's not a default one for scatter plot. You can use a scatter plot which does not use any color to represent, does not color their points at all, and this is still a scatter plot. And any other channel? Okay, and someone says circle, and I would say, and circle is probably better used to describe as the mark, because each circle is representing 1 point. And sorry, one data items. It's not really to represent any particular data attributes. Oh, okay, yeah. So we have position, horizontal, vertical. Yeah, that makes sense. So actually, in a scatter plot, the X and Y coordinates are the two most important channels. And these are the channels always used to represent certain attributes. And so it's probably harder to see here. But what says the X-axis here actually shows the life expectancy. And the Y-axis shows the infantry mortality, I think. And so each of these circles actually means a country. Oops. And then, that's actually, and then the X and Y, we're going to see the actual live examples very soon. Just click down by accident. So the X and Y axis, these, as if you remember from the list, so the XY positions are the most effective visual encoding channels for encoding quantitative or numerical attributes. So that makes a good choice if you have two attributes, both numerical, you want to display. Okay, and in this particular case, which is a bubble chart, and if you also use the color, and which I think represents the continent, and that a country is in. So if you remember the list, color is not the most effective one. But in this case, because X and Y positions are already used, you can't use location again to show the categorical value. So you have to use one of the others. In this case, you choose color. And finally, size. And here, size is used to show population. Okay, and now we can see the actual visualization itself. And so if you click, it goes to this tools, which is an online tool which shows the and the changes or the development of the many different countries over the years. And so that's the latest data, 2019. I think it starts all the way back from 18 something. And then you can change the what attributes is shown on each axis. And if you can see, and it shows here, and the x-axis shows the income. I assume that's the average personal income for a country. And then the life expectancy is the y-axis. So how long people live in the country. And the color indicates the continent, which can be shown here. And so the green ones are the countries in America, blue are the African countries, European is yellow, and Asia is red. And probably this will be China and India for sure, the two biggest ones. And also, I think the size here probably represents. So you can see here, and it says size, it's population. Okay, and so you can change all of these, and that's exactly when you do the visual mapping or do the encoding, and you can decide what these different channels represent, which attributes. So the x-axis can be some other attribute, and the y-axis can be different attribute as well. And similarly, you can change and what color represents. And finally, you can change what did the population represent. Sorry, what the size represents. Okay, and this is actually really designed as a to show how the things change over time. So if you click this one, I hope we should play. Okay, so it's starting from the 1800s. You can see these are the countries there. They have much lower income and much lower life expectancy than what they are there, and then they are now. And the things are gradually moving. You can see the yellow ones are the European countries. They have the higher average income and higher average life expectancy. And you can see there was a dip before. It went quite quickly, but that's actually the First World War. And we're now going to see another big dip. So that's the Second World War. So, but in general, all the countries are having longer life and more income. And now everything is moving towards the top right corner. Okay, that's one example of the scatter plot, or more specifically, bubble chart, which use the color and the size of the circle to represent something. So that's the things, and you need to be aware of using bubble chart. When you have big circles, it can potentially overlap smaller ones. So here, it actually uses the transparency. So it will not block other circles completely. For example, you can clearly see, and these two circles, they overlap, and overlap bit part have slightly different colors. And if you use solid colors, and a big circle can easily block the smaller ones. Okay, and sometimes you might need to do some transformation to better show the relationship and between the attributes. And so here I'm showing a simple scatter plot, which one axis is the carat, which is the measuring the weight of the diamond, and it's a unique kind of unit used to, and I can't remember now, but so it can easily translate from carats to say just grams. And then on the other side, and you have the price of the diamond. So usually, and the smaller the diamond means and smaller weight, and it has less price. And as the weight goes higher, and the price usually goes up. But here, and you can see it goes up, and but the, how do I say, the actual relationship is not that clear. And so what you can do, you can do a simple logarithmic transformation. And so this is what we would call linear axis. So the values are linear. So it's 1, it's 2, 3, 4 in the sense, okay, the value of 2 is twice, or value of 1. And so the distance is twice, or this distance. This works fine, and which is the most common one. But here, if you look at the axis now, and these are actually exponential or logarithmic, depends on how do you say. And so this is 10 to the power of minus 0.6, and this is 10 to the power of minus 0.4. And you can see here, the exponent actually increases regularly. So it's increased by 0.2 every time. So from minus 0.6 to minus 0.4 to minus 0.2 and 0.24. It's similar on this scale. It just says increase a bit faster. So every step is 10 to the power of 0.5 increases. And then in terms of the scale now, it's logarithmic or exponential, and it's no longer linear in the sense, for example, and let's say the distance between 0 and the first tick is this much, but then here, when the distance is twice, the values actually increased more than twice. It's actually increased to 10 to the power of 2, and exponential increase. Okay, but what it shows you here, as you can see now, the price and the weight has a much clearer relationship between them. So it's almost like a straight line. You can fit a straight line through them. And so what it indicates is, say, as the weight increases, the prices also increases. But because this is now a logarithmic scale, and that means this relationship is not linear and actually more like exponential. And so that means when the weight increased a little bit, the price increased a lot. So here we did some simple transformation, and instead of using linear scales, we use a logarithmic scales, and which gives you a much clearer picture of what the relationship between these two axes is. Okay, and so this is all we want to talk about in terms of the scatter plot, and some summary or recommendations in terms of when you should using scatter plot or how you use them. And again, just mention with using the word idiom, so which is the same as recommendations or guidelines here. Okay, and so by default, it's good to show two quantitative attributes. So that will be either the x-axis or the y-axis. And just for scatter plot, the mark is point, and as we seeing here. So if you're using the size, it's no longer, strictly speaking, is no longer a scatter plot. It becomes a bubble chart. Okay, and in terms of channels, you're using both the horizontal and vertical positions. Okay, and this is tasks, and that is kind of effective using scatter plot, and you can potentially find a trend within the data. I say this will be one, and very obviously, and you can see the trend or the relationship between these two attributes, and you can detect outliers. And for example, if you look at this chart here, I'm not sure if you can see, but like I would say this orange point on the right is probably outlier. And this is kind of thing you can quite easily see within scatter plot. And you can see distribution and the correlation. Those are quite similar in terms of trends. And finally, you can see clusters. In this case, you have the blue and orange dots, and they seem to form just one big cluster. They don't really separate, at least not by these two attributes shown there. Okay, and the next one is in terms of the scalability, say how many different data points and you can have. And so, and scatter plot is relatively scalable, and you can have hundreds of points and you still can see each of these points and quite easily. And in theory, and you can have more than that, you can have thousands or even more points in a scatter plot. And but the problem with that is, say, once you have that many of points and you're starting to have this overplotting problem, in the sense, and one point will be drawn on top of another, and then you cannot really tell how many points are there at a particular position. And that's certainly not good for the people trying to understand the data. Let me see, I can quickly find an example of overplotting. Okay. Okay, so this maybe not the best example, and but I think explain the idea of overplotting. You just have many points, and within this region, all you can really tell is there's lots of points there. You can't really tell actually how many, or is that this area is more dense than the other one. So that's when, say, the scatter plot can reach this or go beyond the limit of the scatter plot and can support a number of points. Ooh. Okay, and also, and one thing I didn't quite mention here is what I said, there's no keys and only values. And if you remember, we talked about at the very beginning, what are keys? Keys are the ones you can use as index and to uniquely identify an each point. Here we didn't, so we only just plot two values. And one way to include the keys for the scatter plot, maybe you can, for each point, it will show some, say, IDs as a label of that point. But that's not a part of the requirement of having a scatter plot. You don't have to have them. And usually, and you would not, because if you show the keys for each point, and that will make the whole visualization is much harder to see, it becomes very cluttered. And more commonly, people would show, say, maybe you mouse over each point, you will show some more details, including the key. Okay, and the next one, and I want to talk about is, again, you've probably done this many times before, is bar chart. Okay, and there is actually so obviously it's different from scatter plot, and one difference is it actually has a key attributes, and in this sense, the x-axis is not used to x position is not used to represent any values. Instead, it would show the key usually. And in this simple bar chart, the x-axis shows the different type of animals, and then the y-axis shows average weight for each animal species. So here, and the x-axis is actually a key because you can use these animal type or animal names to uniquely identify different type of animals. Okay, and then the y-axis is used to represent one attribute, usually some numbers, and that's very similar to the scatter plot. Okay, and the difference here is, say, here we are using mark as the, sorry, use a line as a mark instead of an point in the scatter plot. And you could, and using a point as well. For example, we can use to 1 point here and say the point position to show the average weight. That still works, but that's no longer a bar chart. Okay, and then in terms of channels, and obviously the x1 as the x position is also a channel that's used to show the different categorical. Essentially, the key here is a categorical value, and the vertical ones, the y-axis, the second channel is used to see a numerical value, and or quantitative value, which is the weight. And in terms of the categorical value, you could potentially introducing some order, but usually by default, the categorical ones does not have any inherent order. I mean, for example, you can easily just order the x-axis based on their weight, and then you have a completely different order. Oh, okay, and some idioms in terms of using the bar chart. And again, so here's the recommendations when you should use bar chart and how to use them. So first is to say it display two attributes, and one is a categorical attribute, usually is plotted along one of the axes, can be x, usually x, but it could be y-axis as well. And here it uses the position to represent different categorical values. There's no particular order, and doesn't say this value is bigger than that one in terms of categorical values. And then one quantitative attributes, and use the other axis and to show the quantitative attributes here. And the mark is line. And so first, and each of these bars represents a data items, and so it depends on how many data items you have the corresponding number of bars. And also we talked about this before, and we call these lines even, and in practice it probably looks more like a rectangle, but we still call them line because we're not using the width of the bar to represent any attribute. So in theory, you can have a very, very thin bar and it would still work. Usually it would make it a bit wider, just make it easier to see. But there's a width here and is not representing any attributes. That's why we still call the mark as line. Okay. And in terms of the channels, and so we would have the length of the mark, which is a line to represent one quantitative value, which is shown on the y-axis, and then the position on the x-axis to show the value of the key, usually different categories. Okay, and so this is quite common, which you can order the x-axis or the positions of the bars and by the quantitative value, in this case, and it says usage, And this is useful in the sense, if you want to find, say, the minimum and maximum values and in a bar chart, and doing this kind of ordering will make it much easier for this type of task. And also, you can order by other attributes. It doesn't have to be ordered by the Y attributes. You can order by the name of the category alphabetically, or even by some other third attributes, which is not even shown in the visualization. That's also possible. And that's the flexibility, and you can decide what to do. Okay, and then in terms of what type of analysis is good for bar charts, and one task is good and is good at comparing. And so because all these bars have the same starting point, and it's very easy to see which bar is higher and how much difference that is. If you remember, maybe in the first lecture or second ones, we actually did another visualization showing the same data with using pie charts. And with the same difference, it's actually much harder to see in the pie chart compared to in the bar chart. And then also the other is good at lookup values. I actually have to check exactly which type of the search is lookup. And let me just get something quickly. Okay. Okay, and even I can't remember the names of these 4 different type searches all the time, so I have to look them up as well. But again, so here the lookup means the target is known and the location is also known. And I think what that meant in this example, it says, for example, if you're looking for the items and with the largest values, and you would know if you sorted them by the value, you would know it will be either at this end or the other end. So in that sense, the location would be known, but actually the target will not be known. Actually, and the target would not known unless you know which data items already have which items already have the largest value. And so if you don't actually know, then what becomes a browse. Okay, and finally, in terms of scalability, and you can have dozens of bars. That means maybe 10, 20, 30 bars. But you probably don't want to have any more bars than that. And because if you have more than 100 bars, and it's become difficult to tell each bars and separate them from one another. And then for each value, and you can have hundreds of levels. And that means even so you can have very small differences between 2 bars. And because the design of the bar chart, you can still see the difference and very easily. Okay, and now we're going to go into a few more complicated charts. And based on the scatter plot and bar chart we saw before, and you potentially seen these one before, and you just didn't quite realize exactly in terms, for example, what channels or marks they are using. And the first one we're going to look at is the stacked bar chart, which is looks something like this. And so now it's still a bar chart, but each bar it have have several or a few segments. Each segment represents certain values, and they all add up together to form the entire bar. Okay. Okay, and just as before, and the first question would be, maybe I'll explain here. So, first, the type of the values that it represents. And so I'm saying 2 keys and 1 value. And is everyone agree with this, or? Or, okay, if everyone is agree, so I say there's 2 keys and 1 value. And so what actually are the 2 keys then? So the keys, if you remember, is like the index that's used to uniquely identify a data item. And here I'm saying there are 2 keys, so you need 2 to identify each unique data items. But what are these 2 keys? And so if we look at the normal bar chart, and it only has 1 key, and which is the X position, and it's identified each data items, which are represented as a bar, which is a mark. So, and do you think it's 2 keys? If it is, and what are these 2? Or maybe you don't think that's 2 keys, it's only 1, and which is the key? Anyone? No? Okay, and I'll try to explain that then. So obviously, and we're showing a quantitative value, and you might think the quantitative value is the total bar chart, and that could be, but actually, the quantitative value is the height of each individual segment. That's the one that it represents. Okay, and so in terms of mark, and it's a vertical stacked of line marks. So it's several line and stacked on top of each other. So here we still call them lines instead of say bar or rectangle. And there's another name for this in data visualization, is called a glyph. And glyph is just some more complex shape, which is made up of smaller simple shapes. So in this case, the simple shapes is just line segment, and you have several of these which are stacked onto each other, make a slightly more complicated shape, which is called glyphs. And you can have much more complex ones than glyph, or then stack the bar chart. Okay, and so in terms of the channels, it uses both length, which is easy to understand, and how high the bar is indicates some values, but also the color. So the color indicates which part of the bar or the type of the value, because in a static bar chart and in a stacked bar, each section represents a different data attribute, and they add up together. Okay. So actually, and what you can see here is you need 2 keys, and the first is the key to indicate which bar that is. So this is the same as normal bar chart. And the second key is to indicate which segment of the bar is. And then you can uniquely identify each data items. So here, each data items is a segment of the bar, not the entire bar. So the key is the bar and the segment ID. And then you have 1 value. The value itself is whichever segment that represents the value for that. Okay, and it's good and in terms of showing the part to whole relationship. And so you can see how much in terms of each segment contributing to the overall value. That's the type of analysis this visualization is really good or designed for. So you can either use this as a normal bar chart, which you can compare between different bars overall the value, but you can also look at the contribution of each segment towards the overall bar. And so similar to bar chart in terms of number of bars, you don't want to have more than a few dozen, but also in terms of how many segments you can have within each bar. And you probably want to say have maximum 10 different segments within each bar. You don't want to have any more because otherwise it becomes much harder to see. For example, here in this examples for each bar, we have 1, 2, 3, 4, and 5 different segments. But this is actually already very difficult to see these 3, or these 5, because it's very small. And if you can imagine, so if you have 10 or even more segments, and each segment becomes too small and harder to tell. And also actually there's another problem here is because you need a different color for each segment. And once you have more than 10 colors, the difference becomes color and becomes harder to see. And again, difficult to tell whether 2 segments are 1 or 2 separate ones. Okay, I'm going to show a few other examples of or other variations of bar chart. So this one, and these are all less common ones, and this is called a range bar chart. And essentially what it's showing is showing 2 values in one bar. So both the start and end point of the bar indicate something. So it is particularly suitable and when you want to show a range value, in this case, the salary range in company. So you can see, and for the quality assurance, the salary range is between 100K and 152K. So now these bars are no longer aligned anymore. It starts where the minimum value is, or the minimum value of the range is, and stop at the maximum value of the range is. Still, and the actual value is represented by the x-axis, because this is like kind of pivoted bar chart, where usually you would have these bars vertical. And then say for software engineering, the range is between 90K and 160K. So really, what you're visualizing here is the range of the value rather than say the absolute value. That's the emphasis size of this. And this is another variation of bar chart, which is called the waterfall chart. And it's mostly used for to show something like a company finance, or it's kind of to a certain extent it's similar to stack bar chart, and it want to show the different components that made up the bar. And so if you look at this picture, what it shows is this much as sales, and then this much is the income from the service. And so the total income or our revenue would be this much. So essentially what it does is kind of having a stacked bar chart. You can break this bar into 2 parts. One part is one part is income from the sales, and the other part is income from the services. But it actually break it out into 3 different bars to make it clearer. And then you have this side, which are the expenses. So again, you can imagine all these red ones are the expenses, but what is actually separate them out, you can potentially stack them into one bar to show, okay, these are all the expenses. And finally, you would have this much, which is the net income. But here, it's separate out of the research, marketing, and the salary expenses. And if you have the total income and take these out, and this becomes what the so-called operating income. And then finally, you take out the taxes, and that gives you a net income, which is this much. And so it's possible, as I said, it's possible to have stacked the bar chart, but probably will be less clear or not as clear as here. We're going to see the different breakdown of the component. Okay, next we're going to talk about another quite basic and type of chart, which is called the line chart. Okay, and it's actually very similar to a bar chart. So, and instead of having a bar for each data items, it has a point. But also the other addition is you're actually connecting these points. So that's what the line chart is mainly designed for, is to show trend. So we have one key. In this case, it's different, all the different years, and one value. So the one value again is the average weight. Okay, and so line chart, as we said before, and line chart, we're going to have two quantitative attributes, because for the line chart, usually, and the key itself is also quantitative. It's different from the bar chart, where the key or the x-axis, one of the axis for the key, and is categorical. And for the line chart, it's usually quantitative. And the mark is a point and the line. So you use both to show each data items. Strictly speaking, is mostly just point. So each data item is represented a point. And the line is introduced to emphasize the trend or the changes. The line itself does not represent any data items particularly. And in terms of channel, we have the normal X and Y axis, and to represent these two quantitative and attributes. Okay, and in terms of trend, it's used to find, in terms of the type of analysis or task it supports, and really to find trends. So this one you can see how the weight changes over the years. First increase and then it goes down. And the line is there to emphasize this trend. Okay, as I mentioned before, and there's quite a bit of similarity between the bar chart and the line chart. And so when to use which? And so first, it depends on type of the key attribute. And so you use categorical, if it's the key is categorical, like the animal name, or in this case, either male or female, and you use bar chart. And if it's ordered or a quantitative, and then you use line chart. So something like this, and it shows the different years old, the average height between different year old, or the previous ones, say you show this is a ordered or quantitative one, and you can see over the time, you use line chart. Okay, and also the type of task and the design they are meant to support is also different. So the bar chart is really to encourage comparison, to see these are different, which one is bigger, and what is the difference. That's what bar chart is for. Whereas line chart is mostly designed to support identifying trend. So you would like to, if you want to say that, so there's an increasing trend over the years, or depends on the age, I mean, that's the case, you should be using a line chart instead of a bar chart. I mean, in theory, you could say represent exactly the same information as a bar chart, But here, the emphasis now becomes to comparing the height for the 2-year group or to the age group and see which one is bigger and what the difference is. So it's a bit different compared to the line chart, which is to emphasize the trend as across different age groups. Okay, and there's a line chart and should really not be used for categorical keys. So we have the male, female, 2 groups. You really shouldn't using a line chart at all. So there's no, it does not make sense to say that's a trend between the male and the females. You can only really do comparisons between and the 2 different genders. And there's no, because there's no inherent order of these categorical values, you can't really say there's any trend. Okay, and then we're going to again now see a few kind of variations of different line charts. And so this seems to be completely normal, but there is a bit difference. So it's called line chart with axis or scale breaks. And so if you don't look very careful, you will see this is just like a normal chart and there's a peak here. But if you look at the y-axis, what happens is it starts from 600, 800, 1000, and then it jumped to 1800 instead of just 1200, which is what it should be, and then back to, say, 200 increment. Okay, and usually this is done just to save some space. For example, if you draw all the lines, these horizontal lines follow the normal 200 increment, you'll need more space. And this is also can be potentially has downside. So first you have to require experimental effort just to estimate the values of differences. So for example, if you see the differences between this point and this point, and it's actually much larger compared to the difference between this point as this point, even though if you look at the visualization and the vertical distance between those two are almost the same, and just because this part. And as a result, it can be potentially misleading. And because if you don't look at these bar charts very carefully, and you might miss entirely, say the scale is actually not linear, and there's a big break between these 2 lines. If you miss that, you will get wrong answers for the type of, you are likely to get wrong answers for the type of analysis you want to do. Okay, and this is another quite common type of line chart. And so for first, you can plot multiple lines in the same chart. That's very common. And this allows you to say, compare multiple attributes, how they, for example, change over time. Okay, and then, but what's unique in here is each of these lines have a different y-axis. Okay, and so the blue line is using the blue axis, and so its value is from 0 to 100K, and the purple line is using the purple axis. Its value is from 0 to 660K. And finally, the red line is using the red axis. It's from 0 to 50K. Okay. And again, this can be a bit confusing if you didn't pay too much attention to the axis. You might think, okay, all these lines sharing the same axis. Then, for example, you can see here, okay, so here actually the blue line is below the purple line. The blue point is below the purple point. So you might think, okay, at this value, actually at this point, and the purple might have higher value than the blue, but actually that's not the case. And here, the blue value is still actually much bigger than the purple value. Again, this is usually use to save some display space, because you can imagine if we plot everything in the same chart, then the blue line will be way higher up here and would take more space for everything to see everything, to include everything. But again, the downside would be when you squash or using multiple axes, it makes it harder to do comparison. But what it is good at is actually to show the relatively trend. So now, because they are closer to each other, you can see, okay, these three lines, even the values are quite different. The blue ones actually is much higher than the red and purple lines. And their trend is quite similar. They almost go up and down, follow the same pattern, even to less. They're not always exact the same extent, but the pattern-wise, when they're up, down, they are quite similar. And so that means for comparing the relative changes, whether it's increasing or decreasing, ignoring the absolute values. And so for that type of task, and it might be useful to have this different axis. Usually you should avoid this. As I already said, and you can't use this actually to compare the values of different lines because they're on different axes. It's very difficult to say which one is actually higher or lower. Okay, and this is another line chart, and it's called a spline line chart. And the only difference is instead of using straight line connecting the dots, it's using the curved line, which is called a spline line, and it's one way to calculate a curved line. And some people think this is a bit better than the others. But the difference is mostly visual. And also, one thing you need to be careful is saying that gives you a different interpretation between the points. So if you look at this spline line, you might think, okay, here this value is quite high, whereas as you straight line, you can imagine, and for say halfway between the points, it might be somewhere here. Give you a different way of interpolating between the points when there's no data. Okay, and you can also do this kind of line, and instead of using line segments, you can only using vertical or horizontal lines. Again, that's a different design and used for very specific type of data. And so this is usually to show, say, unemployment rate, or sometimes to show interest rate, which, you know, is always either a 0.1% or half, or say a 0.25%. And you can see like this. Okay, and this is actually also quite common. It's called an area chart. And so what it does is it colors the area below the line. And then for different, if you have multiple lines and they have different colors. So here you have the green line and blue line, and you have the area below it covered. Okay, and for this type of visualization, you again has to be careful is to understand whether these two lines or the two area charts overlap or they stack on top of each other. Okay, they're meant different. So exactly, for example, that means for the green line here, and is this value actually 200, say 220? That means indicating the value from here to 0, or is that indicating the value from here to just here? So in that case, it will be less than 200, and maybe like 160 or something. So that is something you need to be careful. I think sometimes people might intuitively think this is stacked, but sometimes it might not be the case. So you have to be careful. Yeah, and so here the example of the stacked area chart. And so because we know it's a stacked area chart, then we know that the green one, sorry, the red one is on top of the or is higher, or starting from the top of the blue line. So this value only really represents this much, which is about 50, rather than say representing between here and 0, which is more than 150. So that's a very important thing. You have to be careful. Okay, I'm going to show you another chart, and this is called horizontal chart. It's less common, but proved to be quite useful to show the same line chart, with less area. So we already see a few examples before when they try to reduce the size of the line chart, but these all come with different problems. For example, they will skip part of the axis, or they will use different axes. And here it's actually using color to try to make the line chart take up less space. So let's say this is our original line chart, and it starts, that's everything. Let's say this is a baseline, for example. That's the part above 0, and this is the part below 0. Let's say that's making profit, or that's losing money, for example. And so what the horizontal chart do then? And it will first divide in the chart into different sections, let's say. And so these are the parts all below 0. And for the part that's above 0, it also further divides into 3 parts. So the light orange, medium orange, and dark orange. Okay. And then what you do is you flip the part below 0. So now these, instead of below, becomes above. But because the color, these are below zeros, and then the larger values are the larger negatives. And for these higher up ones, you move them down. So for this one, you move them further down, it becomes this part. And then for this part, and the second segment further up, you move it down here. And then for the top ones, you move down here. So here again, we're using the color to indicate the values. And you can see for this part, and even this little bar, this vertical position is not high at all, but because it's color, we know this has the highest value compared to all the other parts. And then you can, if you look at the, compared to, this is the original chart, and this is the horizontal chart. You can see it used much less space to show the same chart. So this is useful, and for situation like this, where, for example, it's showing the price of multiple stocks, and you want to stack them. And if you're using the horizontal chart, then each one would take much less space, and you can still relatively easier to see the changes in the line chart. And after certain training. So you can see, okay, here, and that's the price for the Apple stock, because it's all red, all these are going down, going below 0, and these are the ones actually the largest negative values, and so on and so forth. Okay, and this is another one, which is a variation of the stacked area chart, and in this case called the stream graphs. And so it's actually not that different from this one. And the main difference is now you have multiple area charts stacked on top of each other, and the bottom is no longer flat. It's not 0 anymore. And it's also just depends on the values. And so it's emphasizing the horizontal continuity. So you want to keep the green part and horizontally as flat as possible. Obviously it will go up and down. It's not possible to always be completely flat. So in this case, and it's showing the popularity of different band over the times. So the x-axis is time, the height of each band shows the popularity of the music band. So obviously, the higher the wider the segment, the more popular the band is. So here you probably can't see it says something called 40 Winks, which was very popular at that time. This is Mice Parade, and more recently, this is the Hood Internet, which I don't really know what these are. Okay. Again, so this is, you might see it somewhere, and it's more discussed in terms of visualization research and less used in the actual practice so far, but it's getting more popular. Okay, and finally, and before we finish, I just want to show you an animation showing how you can use all these different type of charts and to show the same information and in animation. Okay. Okay, so these are the same type of visualization that we can use to show exactly the same information. Again, we have a line chart, and this is a horizontal chart, and this stacked area chart. This is a screen graph, and this is normal area not stacked, and some other variations. You can just use a bar chart or even just a pie chart. Okay, and that's it, and that's the last one. And in terms of reading, and this will be chapter 7 of the book. Okay, I will stop there now.